calculus? Calculus is to understand the idea of a derived function. The derivation of a function represents the rate of change of the function with respect to a variable. You can think of it as a gradient of the tangent to the curve at a point. There's no need to understand limits, differentiation from first principles. These are several notations used to represent differentiations. First derivative, second derivative. What it really means is you have a small increase in x-axis. This is the formula, some of the more useful formula that you would commonly see when you have a power function, polynomial, x to the power of n. d dx is equivalent to nx n minus 1. Sine become cosine, differentiation of cosine becomes sine, differentiation of tangent becomes secant square. For exponential and logarithmic functions, differentiation of e to the power of x remains to be e to the power of x. Differentiation of ln x becomes 1 over x. A quick example, fx equals to 3x squared plus sine x. This is just plug and play. You just substitute the formula and then you will be able to get the answers. 3x to the power of 2 will then become 6x plus cosine x. One important note to make is you must make sure you are writing the correct notation to represent differentiation. You can also use product rules and quotient rules. These are the formulas. So for an example, if you would like to figure out how to differentiate this, you will then let u to be the numerator, x squared plus 1, v to be the denominator, u prime is 2x, v prime is 1. Then, since this is in the division, you will then be able to apply the quotient rule. So you will have v squared, which is x to the power of 2, then u prime v, 2x multiply x, minus uv prime, so x squared plus 1. So eventually you have 2x squared minus x squared plus 1 divided by x squared. That's the reason why x squared minus 1 divided by x squared would be the answers for these questions. You can use differentiations in some of the following applications, such as to find gradients, tangents, equation of normal. Equation of tangents, as we have seen before, is y minus y1 equals to mx minus x1. So differentiation really can help you to figure out the values of gradient. The equation of normals can be found in a similar way by applying the identity or the idea that two lines are perpendicular to each other if the product of their gradients equals to -1. So which one is the value of m you are going to substitute? It depends on whether it's equation of tangent or equation of normal that you would like to figure it out. In this example, we are talking about a curve y equals to x to the power of 3. Evaluate the derivative, you will then be able to get 3x to the power of 2. Substitute the value of x equals to 2, you will then be able to get f prime 2 equals to 12. The point is when x equals to 2, y equals to 2 to the power of 3, y equals to 8. So at this particular point of 2, 8, at this particular gradient of 12, substitute all the values, the corresponding values into the equation. This is what you'll be able to get. Of course, you can also further simplify it. 12x minus 24 plus 8, y equals to 12x minus 16. That is also fine. You can also use derivative to find the stationary point. The stationary point is when f prime x equals to 0. You will have the maximum point, the minimum point, or what we also sometimes call the point of inflections. Stationary point can be found when you equate the first derivative equals to 0. A quick example, again, in this particular equations, when you derive it, you will then get f prime x, the first derivative, equals to 3x squared minus 6x. or if you factorize it, it's going to be 3x minus 2. When you equate f prime x equals to 0, you'll then be able to get this expression to be 0, or 3x equals to 0, x minus 2 equals to 0, or x equals to 0, x equals to 2. So these are the x coordinate of the stationary point. You have to substitute them back to the original equations. So when x equals to 0, y equals to 0. When x equals to 2, this is 8, this is 3, 4, this is negative 4. Y equals to negative 4. So your stationary point are going to be 0, 0 as well as 2, negative 4. Related rate and small increments. We can actually use this. The definition of dy dx is related to there's a small increment in terms of y versus small increment in terms of x. In this particular case, when the balloon inflates, its radius is increased at a rate of 2 cm per second. So dr dt is increased in terms of 2 cm per second. So that's how we know the way we write the derivative form. Find the rate how the volume is increasing. We would like to figure out dv dt. V of a balloon is considered as a sphere, so it's 4 over 3 pi r to the power of 3. dv dr is equivalent to 4 pi r squared. Radius is 5. Radius is 5. According to chain rule, dv dr equals to dv dt, dt dr. We would like to figure out dv dt, so we will move dv dt on one side and everything else to the other. So it's equivalent to dv dr divided by dt dr, which is dv dr multiplied dr dt. So you can make the substitutions. dv dr is 4 pi r squared and dr dt is 2. R equals to 5, so you have 25, 100, 200 pi would be the answers for dv dt. First derivative test and second derivative test can ask you to figure out whether a stationary point is a local maximum or local minimum. After you conduct the second derivative test, if you substitute the values in, and if that value is bigger than 0, then that particular point is a local minimum. If that particular value is smaller than 0, then it's going to be a local maximum. You can also use first derivative test, which is a little bit more tedious because you have to check the stationary point itself, the stationary point, and a little bit before the stationary point and a little bit after the stationary point. Then only you will be able to check if it is a local maximum or local minimum. So there's a reason why we will usually opt for the second derivative test. Integrations. Integration is the reverse process of differentiations. When you integrate it, if it is an infinite integrate, you must add the constant c. These are some of the more common formula. If you would like to integrate a power function with respect to x, you will then get xn plus 1 over n plus c. Similarly, except for when x has a power of negative 1. When x has a power of negative 1, you will then actually get natural log x. A quick example, if you would like to integrate 3x to the power of 2 plus 2x plus 1 with respect to x, you'll then be able to get 3x to the power of 3 divided by 3 plus 2x to the power of 2 divided by 2 plus x plus c. Make the necessary simplification, then you'll get x to the power of 3, x to the power of 2, x and c. These are the formula for trigonometry functions. Integrate sine x will give you negative cosine x. Integrate cosine x will give you sine x. You do not have to memorize all of this. Everything is going to be listed in the formula. Integrate e to the power of x will still be e to the power of x itself. Here are a couple of different practice questions. So we'll show you guys how to do this. If fx equals to 5x to the power of 3 minus 4x squared plus 7, f prime x is going to be 15x to the power of 2 minus 8x. Find the gradient of the curve y equals to x to the power of 3 minus 3x. We would like to differentiate it. So it's 3x squared minus 3. At x equals to 1, we can substitute. And we will be able to get 3, 1, 3. The answer is 0. So the gradient equals to 0 at that particular x coordinate. Determine the stationary point of fx equals to x to the power of 4 minus 4x to the power of 3 plus 10. Differentiate this, you will be able to get 4x to the power of 3 minus 12x to the power of 2. Your goal is to let the first derivative equals to 0. So 4x to the power of 3 minus 12x to the power of 2 equals to 0. 4x to the power of 2. X minus 3 equals to 0. X equals to 0 or x equals to 3. These are not stationary points. These are the x coordinate of the stationary point. To get stationary point, you have to substitute 0 as well as 3 into the equation. So 0 is going to be 0 squared to the power of 4 minus 4, 0 to the power of 3 plus 10. So f0 equals to 10, 0, 10, 3, 3 to the power of 4, 3 to the power of 3, 10. Press the calculator. Negative 17. So 3 and negative 17 are the stationary points. Integrate 2x to the power of 2 plus 3x minus 5 dx. Apply the formula. Don't forget plus c, because this is an infinite integral. There are not lower and upper boundary values given. A velocity function is provided as such, and we understand that displacement is integration of velocity. So for us to figure out the displacement equation, all we have to do is to integrate velocity functions with respect to t. So 4t squared, 6t, 1 dt. You'll be able to get 4t to the power of 3, 3t squared, t, and a c. Do not forget to do the additional exercises. Thank you very much.